These trig identities are important when it comes to calculus. So in this video, I'm going to just briefly scan through where they came from. So for these four, we will consider this diagram where the angle, one angle is x, the other angle is y. Eventually, it will lead to these four. And this here is very important, and you should know this. Anytime you have a unit circle where the radius is 1, the height is sine, the cross here is cos, and then tan is really the height divided by the cross. And by using Pythagoras, you would get to this. For these two, when you get to calculus, you would be asked to integrate something like this. Now, if you don't understand this integration thing, don't worry. But you would be asked to integrate this. This is quite difficult, so you would replace it with 1 minus cos 2x over 2 dx, and it turns out that this thing will be easier to integrate than this thing. So that's for the future if you don't understand this thing. And these two came from, hang on, these two came from the combination of these two. So hang on, let's try and understand where this comes from. So we would consider this thing here. See this cos 2x, where the two angles are the same. So this angle is x, this angle is x, both the same angle, both angles are the same value. So that would be cos x plus x, because the two angles are the same. So really that becomes cos 2x. So to get this, you would consider the combination of these two. So remember, these two are the same. So that would be cos x, and then cos the other angle is also x, meaning cos squared of x. And then this one here would be minus sine x, and then sine x again. That is sine squared of x. And for you to try and understand where this comes from, you would try and eliminate this by using this here. You would eliminate cos squared. So cos squared is really 1 minus sine squared of x, and then you've got this sine squared, because this here comes from this, because cos squared equals 1 minus sine squared of x, and so on. So you put this into here, and then that would be cos 2x, and then minus exactly the same. So that's 2 lots of sine squared. So that's 2 lots of sine squared, and that's where it comes from. You would rearrange this. So add to hang on. Well, I'm going to add it and then take away this on the other side. So that would be, I'm going to do this in one go. This would then become this cos 2x. And then you would get rid of this 2 by dividing it by 2. That's where this comes from. And then you can use the same technique for cos squared. And then for this one here, you would consider, hang on, for the last one, you would consider this thing, hang on, let me think. You would consider this one here. So this would lead you to this. So let's try and understand where this comes from. It would be same angle. So that would be sine 2x. And then that equals sine x cos, well, the other angle is also x. And then this one here would be cos x sine y, the other angle happens to be also be x. So now exactly the same. That gives you 2 lots. So that's where this comes from. And the reason why this is important, is that in the future you're going to get something like this, which is actually quite complicated for the thing that you would do in the future. So when you encounter this, you would replace it with a block of 2, and then a block of cos x, and then a block of sine x. So you have two separate blocks rather than the combination of two angles. And just to note, there isn't such a thing as this equals something. We just bear that in mind. It only works for sine 2x. There's no similar thing for cos 2x. Okay.